The competency in this lesson is derive inductively the relations among chords, arcs, central angles, and inscribed angles. This is part 2. Specifically, we will be talking about inscribed polygons. An inscribed polygon is a polygon whose sides are chords of a circle. In our figure, the sides of quadrilateral A, B, C, D are chords of circle O. So we can say that quadrilateral A, B, C, D is inscribed in circle O. Or we can say circle O is circumscribed about quadrilateral A, B, C, D. We have 3 theorems in this lesson. The first one is the perpendicular bisector of a chord of a circle passes through the center of the circle. In our figure, line segment CD is the perpendicular bisector of chord AB. So this means line segment CD contains point O. The second theorem is if chords of a circle or congruent circles are congruent, then the chords are equidistant from the center. So line segment AB and line segment CD are chords of circle O, and they are congruent. So this means the distance from point O to chord CD is equal to the distance from point O to chord AB. So we can say OP equals OQ. The third theorem here is if chords of a circle or congruent circles are equidistant from the center, then the chords are congruent. So it's given here that OP equals OQ. So this follows that the 2 chords A, B, and CD are congruent. So we can write line segment AB is congruent to line segment CD. Now we are going to do problems applying the theorems. Problem number 1. The distance from the center of a circle to 2 congruent chords are 3x plus 5 and 2x plus 13. What is the distance of each chord from the center? So this is our illustration. So we have here 2 congruent chords, AB and CD, and the distance from point O to chord AB is equal to the distance from point O to chord CD. So the distance from point O to chord AB is 3x plus 5, and the distance from point O to chord CD is 2x plus 13. Since OP equals OQ, so we can equate these 2 expressions. So we have 3x plus 5 equals 2x plus 13. Now, in order for this 5 to join the constant on the other side, we are going to subtract 5 from both sides. And in order for this 2x to join the 3x on the other side, we are going to subtract 2x from both sides. So we have 3x minus 2x equals 13 minus 5. So 3x minus 2x is x, and 13 minus 5 equals 8. So we have x equals 8. So this means this x here is 8, or the x on the second expression is 8. For our first expression, we have 3 times 8 plus 5, which is equal to 29. And on our second expression, if we are going to change this x to 8, so we have 2 times 8 plus 13, it's also equal to 29. So our answer is 29 units. Problem number 2. In our figure, line segment AB is congruent to line segment CD, and CD equals 12 and OA equals 10. So find AB, AC, and BT. First, we are going to find OQ. Since CD equals 12, so that means QD equals 6. Now we have a right triangle. Since OA equals 10, and this is a radius of circle O, so this means OD is also 10. Now to find OQ, we are going to use Pythagorean theorem, and this is the Pythagorean theorem. C squared equals A squared plus B squared. The meaning is, in a right triangle, the square of the hypotenuse, or the longest side, equals the sum of the squares of the two other sides. So our hypotenuse here, or C, is OD, and we can assign OQ as our side A and QD as our side B. So we have side OD squared equals side OQ squared plus side QD squared. And OD is 10, OQ is the side that we are going to find, and then QD is 6. So we have 10 squared equals side OQ squared plus 6 squared. Now 10 squared is 100, and 6 squared is 36. So we have 100 equals side OQ squared plus 36. Now subtracting 36 from both sides, we have 64 equals side OQ squared. To get rid of this squared here, we are going to find the square root of both sides. And the square root of 64 is 8. So that means side OQ is 8 units. Now, we are going to find side AB, side AC, and side DB. We are asked to find the length of the sides of the inscribed quadrilateral ACDB. Now this is our second step. So since CD is equal to AB, so this means AB is 12. Then OP equals OQ. And since OQ is 8, so that means OP is also 8. So this follows that PQ, which is equal to side AC, and side BD equals 16. Problem number 3. In our figure, the radius of circle O is 13. Then OD equals 12. So find AB, BC, and AC. We are asked to find the lengths of the sides of inscribed triangle ABC. So our first step is to find AD. So we have a right triangle here. OD equals 12. Then since our radius is 13, so OA is a radius, so that's 13. Now to find AD, we are going to use Pythagorean theorem. This is the Pythagorean theorem. C squared equals A squared plus B squared. So our hypotenuse here is side OA. Then we can assign side OD as our A and side AD as our B. So we have side OA squared equals side OD squared plus side AD squared. Now substituting, we have 13 squared equals 12 squared plus side AD squared. 13 squared is 169 and 12 squared is 144. So we have 169 equals 144 plus side AD squared. Now subtracting 144 from both sides, we have 25 equals side AD squared. To get rid of the squared here, we are going to find the square root of both sides, and the square root of 25 is 5. So this means AD equals 5 units. Now since AD equals DC, so we can say that AC equals 10 units. Now our second step is to find BC. So since the radius is 13, that means OB is 13. OD is 12 and OB is 13, that means BD equals 25. And we have a right triangle here. So to find BC, we are going to use Pythagorean theorem again. So this is the Pythagorean theorem. C squared equals A squared plus B squared. So our C here, or the hypotenuse, is this side, side BC. And we can assign side BD as our A and side DC as our B. So we have side BC squared equals side BD squared plus side DC squared. Now substituting, side BC squared equals 25 squared plus 5 squared. 25 squared is 625 and 5 squared is 25. So side BC squared equals 625 plus 25, and 625 plus 25 equals 650. So to get rid of squared here, we are going to find the square root of 650. Now since 650 is not a perfect square, so we will just factor 650 such that one of the factors is a perfect square. So we have square root of 25 times 26. And square root of 25 is 5, so that means BC equals 5 times square root of 26 units. And BC equals AB. So that means AB is also 5 times square root of 26 units. Thanks for watching, guys. This is Teacher Rejil. Keep safe.